Hello everyone, welcome back to our channel. Today we are diving into an exciting topic, how programming languages work. We'll explore the key differences between compiled and interpreted languages. If you have ever wondered how your code gets converted into something a computer can understand, this is for you. Before we go into compiled versus interpreted language, let's answer an important question. Why should you even care? Well, understanding how programming language works help us make better decisions when choosing a language for our project. The way a language handles compilation or interpretation directly impacts performance, as some languages run faster than others. Then we have debugging. Some are easier to debug while others are very hard. Then there are cross-platform compatibility, as some programming languages work smoothly across multiple operating systems while others do not. Did you know the C programming language was originally created in 1970s to rewrite the Unix operating system? At that time, most systems were written in assembly language, but C made it easier to write portable and efficient code. Now we'll understand how compilation works. The first step is writing the source code. The process begins when a programmer writes code using a programming language like C or C++. The source code consists of human-readable text written using keywords, function, and logical structure, but the computer doesn't understand this directly. It needs to be translated into machine code. Then pre-processing comes. Before compilation even begins, the preprocessor scans the source code and makes modifications. The preprocessor handles the tasks like include header files, replacing macros like if you have used use has defined, then it handles these macros. Then the preprocessor expands inline function. It also removes comments. Then the result of this modified source file is sent to the compiler for actual translation. Then compilation happens. The compiler translates the preprocessed source code into assembly language, a low-level representation of the program. Assembly code is specific to the processor architect, example x86 or ARM, and is much closer to the machine code but is still somewhat readable. This is what's the reason why compilation language or programs runs on it, if it is compiled on a specific device, will not run on another device. Then assembly happens. The assembly code is then converted into machine code using an assembler. Machine code consists of ones and zeros, which the CPU can directly execute. Then linking happens. Linker combine object files and external libraries into a single executable file. For example, it resolves functions like printf in C. It connects multiple object files if the program is split across multiple .c files or .c++ files. It provides an executable binary like a.out in Linux or .exe in Windows. Then we have executable file. The final output of a compilation process is a standalone executable file that can be run on a specific operating system and processor. Once compiled, the program doesn't need the original source code anymore. It runs as binary executable. Example of compiled languages are C, C++, which uses GCC compiler. Then we have Clang and MSVC. There's a fun fact that the Linux kernel is written almost entirely in C language. Now we'll talk about interpreted language. Interpretation is a method of executing program line by line, which directly translates source code into machine code at runtime. Instead of converting the entire code beforehand like a compiler, an interpreter reads, translates, and executes the code step by step. You can think of an interpreter as a real-time translator who listens to a sentence in one language and immediately translates it into another. This is different from a compiler which translates the entire document before sharing it. Now I'll talk about the different features of compiled and interpreted language. First I'll talk about the speed. Compiled language are faster than interpreted language because when a program is compiled, it is fully translated into machine code before execution. This means that CPU can run it directly without any extra processing. While interpreted language, the CPU has to run all the things while the runtime. Then we have debugging. Compiled language are hard to debug while interpreted language are easier because, for example, you can understand that the things like segmentation fault and memory leak can only be understand while running the executable and not while at the compilation time. So you can find very hard to find where the segmentation fault has occurred. Then we have portability. So compiled language are less portable as they can be run on the same device on which it was compiled. Interpreted language has no such issue. Example of compiled language are C, C++, Rust, while interpreted language contains Python, JavaScript. Now I'll talk when to use which language. Compilation language is used when we need high performance. For example, if your application needs to run as fast as possible, compilation language like C, C++, or Rust are the way to go. Since the code is translated into machine instruction ahead of time, the execution is lightning fast. Then, in the case of system programming like operating system or game engines, compilation language are used because low-level control is critical for debugging operating systems, game engines, and real-time applications. Compiled language allow direct access to hardware and memory, making them the perfect fit for system-level programming. Interpreted language are used when we need rapid development and debugging. If you are working on a project where quick iteration is the key, interpreted language like Python and JavaScript allow you to write, test, and modify code without computing it first. Then in the case of web development, scripting, or automation, also interpreted language are used. Many modern web applications are built using JavaScript, Python, and PHP because they provide rapid development and easy maintenance. These languages are perfect for tasks like automating workflows, processing data, or script quick solution. So that's all for today. If you like this video, then please like and subscribe. If you have any thought, please comment below. Uh, Thank you for watching and have a nice day.